Okay, so hopefully you watched the videos to find the maximum and minimums of functions. So since my calculator is not working properly in here, I just did it on Desmos calculator. So this is what your graph should look something like on your graphing calculator when you did it. And you should have identified this point as your maximum, which would be 0.71 comma 4.3, and that is your relative maximum. So let's go ahead and put that on. Move back. And that was 0.71 and comma. Got what the other half of that was. 4.3. Now the relative minimum, you can identify off the graph, and hopefully you're able to get this off your graphing calculator. It's down here at the bottom. So that is 3.3 negative 4.3. (3.3, comma negative 4.3). That was the minimum point. So these maximum and minimums are points. There are points. Now we need to take a look at this next thing, which is the increasing interval. So on the graph, where is it going up? So for what values is it increasing? When we look at this, we're strictly looking at domain, which are the x values. The y is either increasing or decreasing, right? So all I'm listing is domain in here. We're going to list it as an interval. So that means we're going to go with parentheses here. And we're starting at negative infinity on the x. And we're going from negative infinity, it's increasing to our relative maximum of 0.71. So 0.71. That's where it's increasing. And then the graph at the top changes direction. So anytime you have a turn, you have a change in direction. So that interval goes from really close to 0.71 and continues to 3.3, because that's where it changes direction on the minimum. And then after 3.3, it starts to increase again. So we have to put what's called a union in here, and we're going to have to connect it from 3.3 out to infinity. It is increasing. So there's two places on the graph where it is increasing. All right. So that's how you use your max and mins to find your increasing and decreasing. Well, let's apply that to this problem, and you'll have the others to do. Now, the thing with these, just like with the quadratic, domain is always double bar R, or you could write negative infinity to infinity. So the domain, all the x values you use, we're not cutting you off. Okay? If it was an even function, your range wouldn't be all real, but odd functions. See this 3 up here? Odd functions is negative infinity to infinity, or all real values for that. Okay? Some other things we can do before we even graph it. We could talk about end behavior here, because we know what that is. Right? If we look at our leading coefficient, it's negative. It is negative. So as x goes to the right, f of x we know goes down to negative infinity. It's going down. So negative leading coefficient means that the infinity side goes negative. Now we look at this. This is the odd function, and odds go opposite. So that means this side goes to infinity. That wasn't too hard to do there. Okay. So now I need to get some points off the graph. Okay, so I can tell you right now, I know this function, and I can do a factoring on this. So if I factor this, I end up with x squared coming out, and in parentheses it's going to be x plus 3. X minus 3. I'm sorry, I'm factoring out. No, x plus 3. Yeah, so this is a negative x here. That's a negative x there. Okay, so this tells me when I set this equal to 0, and we'll talk a lot more about setting this equal to 0, just like we did with quadratics, that at x, if I made this 0, or if I solved this and I made x 0, that means 0, 0 is a valid point on this. And since it is squared, I can tell you it does a thing called a bounce. Now, we can go out to 1, 2, 3, right there, and that's where it crosses the x-axis. I do know that. And if I remember correctly, the maximum's at 1, 4. Let's see, 1, 2, 3, 4. So that's here. And since I know the end behaviors, I know this side is coming down. That's a, right? And then bounces off, goes to the maximum, comes back down. Remember, graphs are nothing more than sketches. They're just simple representations of kind of what's happening. It does not have to be perfect. So now if I look at this, starting at negative infinity over here on the x, because remember, if we're talking about the intervals, we're talking about domains. So from negative infinity to 0, negative infinity to 0, we are decreasing, right? So this is a decreasing interval from negative infinity to 0. That's where the graph is going down. And then it changes direction there, doesn't it? It changes direction at 0 and increases to 1. So an increasing interval from 0, comma to 1. That is our increasing interval. And there, at the change of direction, at the maximum, it changes direction and it decreases. And that decrease goes on forever out here. So we have to union and go from 1 to infinity on the decreasing side over there. All right, we already did point out a relative maximum. The relative maximum is going to be at 1, comma 4. And we have a relative minimum, which is going to be at 0, comma 0. So there you go. Max and mins you can find on the calculator. And then you have to identify your decreasing interval. This one has a really small increasing interval and then another decreasing interval. And that's how you would do these problems. And you have a few to do on this page. Sketch the graph and tell me about range domain. This one has a range that does not go to negative infinity because it is even, so be careful. Okay. This one does not go to positive infinity because it's negative. You flip it upside down. And the last one, it is odd, so all real for the range. So when I was telling those things, it was about the range. All right, guys, we'll take a look at these again when I return to class on Thursday. Remember, we have a quiz on real simple end behaviors. Okay, not this graphing. Graphing won't be part of it. All right.